Hello, in this video I will be showing you two common tree searching algorithms, DFS, depth first search, and BFS, breadth first search. So what a tree searching algorithm does is, given a tree, we want to search each of the nodes and see if the target value exists in the tree. So the tree does not necessarily have to have any particular ordering. So if this was a tree, let's say 1, 3, 0, 5, and 9, then what a depth first search does is recurse into the child nodes, propagating the results of the search upwards, and we use recursion to accomplish this. So that's how depth first search actually works. In breadth first search, similarly, we want to find some target node. Okay, but the key difference here is that, say we outputted the result of breadth first search at each of the different levels, we'll actually see that it goes level by level. So here, where it will recurse 1 to 3 and then 0 to 5, what this will actually do is look at each depth at a time, each level in the graph. So firstly, we'll have 1 here, and then we'll see 3, 0 here, and lastly 5, 9. So at each of the different levels. So this, again, is depth first search. This right here is breadth first search. So now I'm going to show you an implementation in JavaScript, and we're going to need a couple of things to start off. So we need a JavaScript tree, which will consist of nodes. Because there's no particular ordering in the tree and we don't need to keep track of length, the only value we need from this tree will be the root node. So this will also still be a node. So we'll just need to classify what a node is, and it will have a value, and then it will have children. Okay, so that's our simple node structure that we're gonna have. So to get started, let's call this BFS, and we're first going to need the node class. In the constructor, we're going to initialize a couple of things, which will be the value equal to the value that we input to the constructor, which I'll bring in just a moment, and then also this dot children is equal to an empty array to begin. Okay, so that is our node, and we're gonna have a method here called add child, and this is going to take in a node, and then it's going to push in the node to this children array. Okay, now we can console log the nodes that we instantiate pretty easily using JavaScript, so I won't have any additional method for printing the tree. I think that should be okay. So that is our node class, and now I want to set up the exact same tree that is depicted here. So top level root node will be 1, and the second level will be 3 and 0, and the leaf nodes will be 3, 5, and 9 accordingly. So how I'll do this, let's just start off with the root. So let root equals the new node 1, okay, and the left subtree of the root will be new node of 3. The right will be new node of 0. And here we're going to add a child to the root node, which will be left. And here we need to add 5 and the 9. So let's first let's first just directly add the children nodes. So new node 5, and right dot add child new node 9. So we can console.log the entire tree by just console logging the root. And it's not verbose, but that is because I did not add the right child to the root. So we should see our full tree, and we apparently have some circular reference. So root.add child, we want the right node. There we go. So now I want to start off by implementing the depth first search algorithm, and this will be a function called DFS. We'll take in a graph, and it will take in let's just say root, because we want to pass in the root anyways, but we can search from any node in the tree, and we're looking for a specific target value. Okay, so in the depth first search algorithm, again, it is recursive, so we're going to take let node equal to the root, and then we're going to recurse into each of the children nodes. But before we do that, because we want to just check the base case that if node.value is equal to the target, then we're going to just return true. Now recursing into the children for const child of node dot children, we're going to return the value of depth first search child, and we're going to pass in the target. Now we don't want to return here at the first level. Actually, we want to say if depth first search returns true from the base case, then we're going to return true in the outermost loop. So this will recurse into all of the children nodes in order. If it does not find anything, then we finally return false. Okay, so we can test this out here by calling depth first search console.log depth first search, and we're going to pass in the root node, which we have up there, and we're going to pass in 9, which does exist, and then we're going to pass in 10, which does not exist. So this should return true and false respectively. There we go. That is the depth first search algorithm. Now to implement breadth first search, we will no longer be using recursion. We will be using a queue-based implementation. What this queue will do is, well, we're going to be adding each level into the queue, and we're going to do all of this in a while loop, so long as the queue has not been exhausted. And then we're just going to shift, basically pop, but popping the first element because it is a queue. And then we're going to check each level in that manner. So we're going to go level by level using a queue. Okay, so how we do that, defining using the exact same input parameters. Let queue is equal to array with the root. Now while the queue dot length is greater than 0, we're going to select the first node in the queue in a FIFO manner, so in first out basis. And we're going to use the JavaScript queue.shift method. And this is similar to pop in that it will mutate the original list and return to you that value. So if node.value is equal to the target, then we're going to return true right here. Otherwise, we're going to push all of the node's children's, and we're going to use the spread operator because node.children is an array, queue is an array. We don't want to push an array to an array, so we're going to spread out using 3 dot signs. Okay, and you see how because we're pushing in each level at a time using node.children, this queue.length condition will run until we reach the last level. Upon reaching the last level, if we have not found the value we're looking for, then we're going to return false. Okay, so similarly, we can test out using the same test cases here, but just calling BFS instead. So BFS, which should return true and false sequentially. So there we go. That is the depth first search and breadth first search algorithm written in JavaScript. Thank you.